recorder. Recorder, you put everyone's name on that paper. You use yours. And everyone else, recorder for using your paper. Put everyone in your group. Put everyone's names on that paper. That's what I'm going to do. Okay, give me 5 minutes though. I'm giving you 5 minutes. Yeah, starting now. Write your name down.
Or that I'm like very busy, like business, and or it's just the feels for like people look at it like no. If I stay, she told me during the day.
Did everyone finish reading that? Okay, can I leave it like that? Can you guys see the graph back there?
Yeah, we can.
How about that?
I just get from there. I didn't know about estimate.
Can you see it? Okay, someone come up and look at it then. If you're the whole table's having a hard time seeing back there. Who's having a hard time seeing? All of you. And then come on up, sit up front then. All 4 of you. And discuss it. I don't know how else to show you, but to have it like that. If you need to, stand on up. Near the back table, you won't distract anybody. Otherwise, I think you guys need to watch. It doesn't bother me. You're back here. You're not in.
Yeah, you really thirsty. No, my voice was like, that was like way over there. No, it literally does that during this whole day.
Put that back in the cup.
I can't yell. I was like, it's like apples, books, cats, stuff. Okay, estimate A, I don't know what this is, but no, I'm just gonna make a little non-straight. So 9 to 11. Oh my God.
Ready?
This doesn't seem right, guys. You know, Vanessa's supposed to be the fuss and bad, but she loved us.
Hey, you gotta finish
Vanessa
that.
and
I know, right now. Why would you think down? Why would you work down? It's not nice.
45 minutes. You don't need to use whole numbers.
I knew it. I put some
You don't
45.
have to use whole numbers.
Miss Wilcox, I used
I
to.
said 5 to 5:30. 6 to 6:30.
What do I do?
And
And that's 6. So
all right. Who's confused?
Oh my God, sir. I feel like I'm a guy. Stay with us. I wanted to do this. Now I'm like, oh God.
Okay, let's look at this.
Give me the
The
sock.
interval can be, time interval can be just 1 hour, just that set of hours too.
Give me the
It
sock.
doesn't need to be 5 to 5:30. Anyways, Aaron was at work 30 miles from home. What time was he at work? At 5 o'clock, right? At 5 o'clock, so he's still at work here at 5. The time interval is just 5 p.m. Does that make sense? Because he's still at work. And how many miles is he at? 30. 10, 20, 30. So right there. So he's 30 miles from home, right? He's 30 miles from home like this, correct? Yes. And then just pay it, if you don't, you're okay. I'm not going to collect this, don't worry, just pay attention. Shh, because most of you didn't get it. Okay? Because of rush hour, she traveled at a steady rate that arrived at home 45 minutes later. So from 5, this would be from 5 to what? 5:45. She arrived 45 minutes later. Here's 6 p.m. right here. Here's 5:45. 45 minutes later is at home right here at 0 miles. Correct? 5:15, 5:30, 5:45. Make sense? Okay? She's at home. After home, she took an hour and 15 minutes to cook and eat. Did she go anywhere? No. So 5:45 plus an hour and 15 minutes is what time? 7 o'clock. 5:45 to 7 o'clock. She stayed home. So from here to here is a flat line. Make sense? Because she stayed home. Immediately after dinner, Aaron left home and traveled at a speed of 60 miles per hour to a town that's 1.5 hours away. So from 7 o'clock, 1.5 hours, what time? 8:30. So from 7 to 8:30, she went how many miles? Not 60 miles, she went 60 miles an hour. How many miles did she go? For an hour and a half. So for 1 hour, she went 60 miles. And then 30 more miles for half an hour, correct? Does that make sense? How many miles did she travel? 90. So here you need to go up to 90. At 8:30, you have to go 10, 20, 30, 40, 50, 60, 70, 80, 90. Right there. And that's her time interval, and that's the graph. Does that make sense?
Yes.
Why was it hard?
Just like right. You don't. I got it right. You didn't know.
You got it? Who understood and tried to convince their table?
They didn't listen to me. And I'm later.
Okay, put the markers back.
You
All right.
didn't want to hear nothing.
67 of your text. 67. Go to this problem here. That wasted a lot of time. Anyways, problem number 1. This type of thing is called mapping. Okay, this is called mapping. This is called mapping. Okay, there's the word mapping. Write this sets of ordered pair that represent a relationship in each mapping. Okay, so if you look at this, this is relatively easy. This is your X. This is your Y. Okay, this is the domain. This is the range. This is your input. This is your output. That's what output is, an answer. Notice, okay? This is the independent variable. These word means the same thing. This is the independent. And these are called the dependent. Sorry. Okay, all these words, these sets of words means the X. These sets of words means the Y. Got it? All mean the same. You'll hear these words interchangeably. Input, domain, X, independent, dependent, range, output, answer, all means Y, or f of x. Oh, also f of x means y. Yeah, or f of something, function of. It always means, f of something always means the answer to the problem. Yeah, all means the same thing. I'm telling you because I was confused. Some teachers use them and I'm like, what? Doesn't make sense to me. Okay. Show me at lunch and tell me at lunch. Okay, now they want you to write the ordered pair, sets of ordered pairs. So ordered pair for the first one is 1 going to which number? 7. So it's 1, 7. 2 is going to which one? 1. 3 is going to 5. 4 is going to 3. Those are your ordered pairs. Now this is called a function. Notice that none of the x is repeated. This is called a function. This, in big capital letter, put function. None of the x is repeating. Did any of the x goes to a number twice? No. Not. Look at all the x. 1, 2, 3, 4. None of the x is repeating. That means it's called a function. You understand? Look at C. Look at letter C. Letter C is not a function. We'll write out the ordered pair. 1 goes to which number? 1. 2 goes to which number? 3 and 2 and 5. Not a function. Notice why it's not a function? Yes, because there are 2 x's. The input are the same. The independent variable are the same. It is not a function. Do you understand? We can write all the ordered pair because they asked us to, but it's not a function. 3 to 5, 4 to 7, and 5 to 7. Do you know why it's not a function, right? X, 2x are the same. There's a here and here for the x. Notice the x here are all different. Notice all of these are all different for the x. Get it? Tell each other why the second one is not a function. Okay.
No race.
Okay. Now, number 2, create a mapping. Okay, let's create a mapping. Where this is 5. That's your x, 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 correct? 5 and then 6, correct? 8 and then 11, right? We got all our x? Yes. Yeah, there's a 6 right here. Most of the time, yes. No, in order. Put it in order. We put it in order. Yes. Yes. Put it in order. And then the range is 8. Notice that the y is 5, 8. Do not write it twice. Write once. This number 8. Notice there it's twice up here, right? You only write it once. 8 and then 9. This is a function. You know why it's a function? Is this a function or not? Yes. Why is it a function? The domain are different. The x are different. Tell each other why it's a function.
Don't have to say why.
Okay? 5 to 8. 11 to 9. 6 to 8. It doesn't matter about the range. It only matters about the domain, the f. 8 to 5. That's called mapping. Any question on mapping? No. Okay? Okay, these are sets. These are called sets of ordered pairs. The symbol here, this little nice symbol, that's called a set. The nice little symbol, boys and girls, is called a set. These are sets of ordered pairs. These are sets of ordered pairs. Okay, to create a map. Okay? All right. You know how to write ordered pairs for these, right? -2. Is this a function or not? Function or not? Yes or no?
Yes.
Input is x, right? Are any of these repeating? No. Is it a function or not? Yes, function. Second one, is it a function? No. Function. Not. You. Okay, why is it not a function? Tell each other. Tell each other, please.
Because there's double axis, there's two sets of doubles.
Okay, you guys know how to write ordered pairs for these? Yes. Okay, -5, 10, 0, 0, 5. It doesn't matter about what. We only concentrate on that. We're talking about function and not function. We only talk about the input, not the output. Just the domain. All means the same.
That's a good one.
That's the domain.
Make
It's
a
variable.
variable B. I'm gonna make you next.
Okay.
She wants to date.
And all of this is talking, everything is a relation. If they say, is it a relation? Everything is a relation. Is it a function or not? It depends. Okay? A relation is sense of order pair mapping. It doesn't matter. I hate definitions if you don't see it. I've gone over what's a function. This is all the same thing. Look, state why the relation in the example shown is not a function. I want you to tell each other why this is not a function right now. Why is it not a function?
Yes.
Because 2 and 5 are 5. All we got are 5 and the x side is that far, right? Right? No, that doesn't require the order down.
Okay, I want you to state the domain and range. To explain right here why it's not a function. Because the 2 repeats twice, right? Or 2, the domain repeats twice. Domain of 2 repeats twice. State the domain. What are the domain here? 1, 2. This is page. What page is it? 70. 1, 2, 3. Do we write 2 twice? No. Even though it went twice, we don't write it twice. Domain. Domain is what variable? X. It's also called input. It's also called independent variables. All those wonderful names. Okay, what are the range? 1, 3, 5, 7. Even though 5 is repeated twice, we only write it once. Do you understand? Yes. Okay, that's basically all it is. Huh?
I just wrote down the numbers on the last part.
I went too fast?
Oh, wait, no.
I didn't even read the question. On numbers 5, you're supposed to answer question 2 and 3. I don't really care. I just want this to relate. Otherwise, if I follow the lessons exactly what's here, it would take us all of lunch too. And it's basically repeating itself over and over.
I got it.
Okay, got it?
So a word for me.
Is she correct? Is this person correct? Is Emil correct?
No.
No. We know why, right?
Yes, because
Go to not using the book at this time because if we do everything this book says, we won't get through it. Okay, a vertical line test. If you do a vertical line test, that means through each point, draw from the domain. See the domain, the input, the X. Draw it through. Notice only one point went through it, right? Only one point went through the line. We're drawing a vertical line because there's only one point per line that we draw through. This is a function. If you write these points down, 1, 1, 2, 3, 3, 1, 4, 4. Is any of the domain repeating? No. It is a function. Now look at B. Go 1, 2, and 4. Notice that it went through twice. This ordered pair is 4, 2, and 4, 4. Is it a function? No, not a function. So you can draw a line really fast in your mind without writing the ordered pair to see if it's a function or not. This is not a function. It does not pass the vertical line test. You get what's a function and what's not a function.
Yes.
Okay? Now, vertical line tests, see, they're just explaining what I just explained to you. Okay, is this a function or not? Draw a vertical line through each input and see. On page
76.
76. Draw a vertical line. Is it a function? No. You draw a vertical line, not a function. To prove it, you can put this one here as 2.5 and 3.5. Here, 2.5 and what? 2.2 or something like that. So, does not pass the vertical line test. Make sense? Is B a, it doesn't matter. Some other one you can put it right here. You can put it anywhere and you'll see that any point there, when you have to write the ordered pair for it, the domain, the X, will repeat anywhere on there. So it is not a vertical, it is not a function. So here, don't confuse, at any point, notice this is not a function, even though here it only went once it's twice, just one time, it's automatically not a function. Got it? Yeah. Okay. This is a function, right?
Yes.
Because if we draw a vertical line, it never passes this twice. Let's call it a function. Okay, let's do this part. To 62, what page am I on? Okay. Determine if the equation is a function. List 3 ordered pairs that are a solution of each. So you need to, basically for this, put your X, list 3 ordered pair. What do you want your first X to be? 0? I'm going to make X 0. Remember this last year?
Yes.
X is 0. What's the answer? The answer is always Y. If I input, I substitute in X is 0. What's my output? 3. My Y, my answer, my dependent variable is 3. My range is 3. That's first point. So second point. No. My domain will not repeat. So is that a function or not? It's a function. 5 times 2 plus 3 is 13. It's a function. Now I'll show you one that's not a function. These are all functions. Yeah. You just substitute numbers in your first ordered pair. What is your first variable you want? 0, right? Always do 0. If x is 0, 0 squared, what's my answer? 0. If x is 1, 1 squared, 1. Okay? Sorry. If x is 2, 2 squared is 4. Is this a function? Yes. The domain are all different. Okay? I believe this is all a function. I'd have to do. See one that is not. Remember, I'm going to have this on Facebook too, so if you get confused on what's a function and what to do, you can go back. Just fast forward and look at the part you need. Yeah. Oh, sorry. Any question? And I'm looking to see if you are checking. If your answers are wrong, I know you're not checking YouTube, are you? Okay, function or not? Well, you know what a function or not. Any question on what's not a function?